Pre-statistics, graphing quadratic functions in standard form, part 2. Lesson objective: graph a quadratic function in standard form using the vertex formula, and also using the graphing calculator. We'll begin with an example. Example 3. Sketch a graph of f of x equals negative 2.2x squared plus 6.1x plus 1.4. We'll do this algebraically first. Solution: first we write down the coefficients. A is negative 2.2, B is 6.1, and C is 1.4. Now, because A is a negative number, this vertex will be a maximum value. So to find the x-coordinate of the vertex, we take negative 6.1 divided by 2 times negative 2.2. A negative divided by a negative is positive, and 6.1 divided by 4.4 is approximately 1.39. To get the y-coordinate, I substitute 1.39 back into the function. We square first, then we multiply, and we get a value of 5.63. So the vertex is 1.39 comma 5.63. And again, this is a maximum value because the value of A is negative. We can find some additional order pairs. For this example, I'm using inputs of 0, 1, 2, and 3, and substituting each of those inputs into the function gives me the corresponding outputs of 1.4, 5.3, 4.8, and negative 0.1. On graph paper, we see when x is 0, we have an output of 1.4. This is our y-intercept. Here we have our vertex, and here we have the corresponding 3 order pairs. When we have decimals, this is very tedious to put on graph paper, and I suggest using the graphing calculator, and that's what we're going to do next. We go to our y equals. We type in our function negative 2.2 x squared plus 6.1x plus 1.4. We're in the standard viewing window. We hit graph, and here we see that this is a vertex. That's the maximum. And I'm going to change the window settings to zoom in on this a little bit more. I think I'll let my x min be negative 2, my x max be 5, negative 2, 5. I'll count by ones. Let's see what this looks like. Yeah, we have a better picture. I can use the maximum feature, which is second, and trace, which is calculate. We want number 4. It's first going to ask for a left bound, so I'm going to go to the left a little bit, hit enter, scoot over and give it a right bound, hit enter, and then have it guess in between, hit enter. And here we see the maximum is approximately 1.39 and the y value is approximately 5.63. Okay, we can also use our table, and the table sets counting by ones, and we can see as we go back the numbers are getting smaller, and as x increases the numbers are getting larger until we get in this area, and then the numbers are getting smaller. So we can see that the vertex is likely occurring between 1 and 2. So let's go to table set. Let's have this start at positive 1, and let's count by 1. So now we see that the maximum's in between 1.3 and 1.4. And if we need to be more precise, we can count by something smaller than 0.1 and be more precise. Let's do another example. Example 4. For h of x equals negative x squared minus 2x plus 8, find the following. Number 1, what is the line of symmetry? Number 2, find the vertex. Number 3, find the y-intercept. Number 4, find the x-intercepts. Now we'll do this graphically and numerically because we don't know how to do this algebraically just yet. But we will. Number 5, and then we sketch the function. So let's begin. So the line of symmetry will be found by using the formula negative b divided by 2a. And in this case, we have a negative negative 2, which is a positive 2, divided by 2 times negative 1. So we have positive 2 divided by a negative 2, and that, of course, will become a negative 1. Substituting negative 1 in, we can find the vertex, the y-coordinate of the vertex, I should say. So f of negative 1 gives us negative 1 squared, which is 1. We multiply that by negative 1 minus 2 times negative 1 plus 8, and this gives us a value of 9. So the vertex is negative 1, 9. We also know that this vertex is a maximum because the value of a is a negative 1, a negative number. For the y-intercept, we let x be 0 and we solve for y. So we have 0 squared, which is 0, times negative 1, which is 0, minus 2 times 0, which is 0, plus 8. So this turns out to be 8. And if you'd like to know a shortcut, the y-intercept is always the value of c. So our y-intercept 0, 8. To find the x-intercepts, we let y be 0, or h of x be 0, and then we solve for x. Now there's a number of different ways of doing this. There's such a thing called factoring. You could also use the graphing calculator, and this is what we'll do. And in a later video, we'll solve this by using what's called the quadratic formula. But we will look at the x-intercepts in this video by using the graphing calculator. It does turn out that the x-intercepts, there's 2. When x is 2, y is 0. When x is negative 4, y is 0. We'll see that on the graphing calculator. And then number 5, to sketch, we have a x-intercept of negative 4 and a positive 2. Our vertex is a maximum and occurs at x is negative 1 and y is 9. And we have the important features of the parabola. We have our y-intercept, which is 0, 8. We have our vertex, and in this case we have 2 x-intercepts. This is what the graph looks like on the graphing calculator, and I'm going to show you how to find these x-intercepts using the graphing calculator. We have our function in y1. We hit graph, and here we see an x-intercept, and here we see an x-intercept. So if we go to our table, we're looking for x values where y is 0, and we see that happens when x is 2, and then after 2 the numbers are getting smaller. If we go to the left of 2, we can see our vertex happens at negative 1, y is 9, and when x is negative 4, y is 0. So that's another x-intercept. And parabolas can have 0 x-intercepts, 1 x-intercept, or at most 2 x-intercepts. And this is the case in this example. We have 2 x-intercepts. So here's our sketch of this quadratic function, we can clearly see what our x-intercepts are, we can see the y-intercept, and we can see the vertex. Thanks for watching.